Hi everyone. In the autonomous connected vehicle lecture series, now this video we discuss about the land keeping assistance using LabVIEW. Now you have to vehicle autonomous vehicle driving within the land. Suppose you have to move away the land position means you have to change the steering to you have to maintain about the same land position. Used by that various sensor to you have to sense the land position. Now we discuss about the basic theory. The next we have to the same theory we are implement in the LabVIEW platform. So now is the vehicle deviation left or right from the land center. We want to maintain about the vehicle maintain about the center point. Suppose the deviation means is the land problem. So that deviation we have to find out the land error. Then we have to use by the steering control to we have to return back to the land position that is needed for the steering control. Then saturation. Now we maintain about the closed loop control. The basic theory related to the land keeping assistant. Okay, so land keeping assistant is the lateral ADAS function, one of the ADAS function that helps the vehicle remain centered in the land. For simple model, the lab central is assumed as 0.5 and the land position range from the 0 to 1. The land position range from 0 to 1. The middle point we consider for the 0.5. The proportional control convert the land error into steering angle. The saturation prevents unrealistic steering command. The land error is the land position minus 0.5. The steering angle Kp into land error. So steering limit we consider for the 30 minus 30 degree to plus the 30 degree. Now we have to find the new land position, the old land position minus kV into steering into dt value. Old compared with the old land position and minus kV into steering into dt value. This is a land keeping architecture. So now we taken about the land position and based on the different sensor to identify the land error. Then from the land error we have to given to the controller, KP controller. For the basic level we use in the P controller, KP controller multiply with the error. Then we find out the saturation angle, so plus or minus 30 degree. Then what is the vehicle response and the feedback. Okay, the goal to make the learner to error approximate 0 here. We want to maintain about the land position is the middle point. The steering gain convert must be the consideration. The shift register can be used to store the update the land position between the loop iteration. This is a basic diagram for the front panel and the block diagram. Here is the front panel. So here we can support for the various land position and the KP gain value. We will gain representation KB times step dt, the stop button, the various indicator, land error, steering angle, and the updated land position and the steering versus time chart. So each experiment we have to record the data, that is the steering position versus time chart. The previous experiment we use in the speed versus time. Now this experiment we use in the steering position versus time chart. This is the LabVIEW block diagram logic. So to subtract, so normally you have to land position, subtract with the 0.5, that is the constant value. So subtract with the 0.5 constant value to identify the how much land error. From that land error, we do the multiplication. So Kp into error value. Then saturation point. So plus or minus plus 30 degree to minus 30 degree. Then vehicle response and we record the data by the graph sheet too. We have to record the data. Then land error is the land position minus 0.5 steering into KP land error. The new position is the old minus KP into steering. So we have to stop button to we have to end the. This is a step-by-step procedure implement in the LabVIEW platform. And now we have to create the land position under KP control. So normally we want to record and we want to continuously running. We use by the while loop. Place the while loop and wait in the milliseconds or 100. We use the subtract 0.5 to identify the land error. So multiply with the KP2, we identify that exact steering angle position. So use the range position to minus 30 degree to 30 plus 30 degree to identify how much change is shifted to the land position. Display the land error, steering angle, and a chart inside the loop. For automatic closed loop model under vehicle gain and a shift register, update the land position using the steering correction. So run the VA and observe the error moving towards the zero. So tune the KP and KB for uh, smooth control. So KP value and KB value, land position, you know about the 0 to 1. Land center, we have to maintain about the zero point 0.5. Then KP KB value. So steering limit, we taken about the plus minus 30-degree value. Tuning guide, now we are to initially we start with the normal condition, just change to the learning portion to identify the KP and KP tuning value. So these all are in the some expected output. Land position, from the land position to identify the steering angle. Land position 0.5 means zero error. Suppose 0.8 means we consider for the positive error. So 0.2 definition for the negative error. So high KP value for the false corresponding and possible oscillation. Okay, during the experiment learning, we can identify we vary the KP value to how it is the response in the system. These are the some basic mistake added during to the and we want to do the troubleshooting. We have to use the stop button and use the range we want to use by the zero point 0.5 constant to identify the land error. Then age range is the minus 32 plus 30. Check the sign to steering correction. So they use the waveform chart to live steering and time display. Use the shift register for the automated closed loop position updation. This learning outcomes survey. After completion of the experiment, student can learn about explain the land error and the land center, complete the steering angle from the proportional control, apply the saturation in LabVIEW, build a basic closed loop land center model. So next learning startup, we have to identify system information, predict the collision risk, forward collision one. So student can learn from this experiment. So run the land position 0.2, 0.5 and 0.8 and we have to identify how much error we can obtain. Record the land error and the steering angle. Try to KP values vary and achieve. We have to go with the higher value to achieve the smooth response. Some of the basic questions. Identify the land error. Why is the 0.5 selected in the land center? What happened when KP is high? Why should steering angle be limited? The basic five of question. So this is the basic theory related to the land keeping assistance using the land keeping assistant. Now you have to go with the LabVIEW experiments for the land keeping assistant. Okay, I want to do in the create a new project. So blank VA. Okay. So now we taken about the uh, land position. How much land position? Here, click numeric and now position. So this is we taken about the land position. So here we vary from the land position to 0 to 1. So minimum value is 0. So scale we taken about the 0 to 1. So need for the display. So digital display. a land position from the 0 to 1. So this land position we want to compare with the 0.5 value. So there is a 0.5 definition for the middle position. So we want to identify the error. Before we want to do in the while loop. So structure while loop. Here's the land position. So I want to compare this one. So subtraction. So numeric operation, we want to do the subtraction. First value minus second value. The create constant. Okay, so create constant values. Now we want to display the land error. Just we want to make it the just display the error value. So the numeric and just indicate the values. So here's the land error. So yeah, land error. So that's land position out connected to the land error. Just whatever values compare with subtract with the point and identify the land error. That land error multiply with the KP value, the gain value. Now we added with the multiplication, the multiply symbol, that error value multiply with the KP value. Here I put the KP6 value. For high value, we can get in the fast response. So is the KP6 is the constant KP value. Then multiply with the land error. Just we have to range between the 30 degree to minus 30 degree to plus 30 degree. So that's a comparison range, and we have to find the minimum range to maximum range. The upper side is the limit and upper limit. So we take a number the plus 30, create constant. So that's the 30 degree, positive 30 degree. The downside is the negative 30 degree. So negative 30 degrees. Now this is value. So this is I want to display the angle position. So the steering angle here, how much steering angle here? Steering error. So this is the range from the minus 30 to plus 30. Scale, we taken the minus 32 plus 30 degree. Okay, steering error we connected. So how much error value? Now we want to need it for the steering angle. Yeah, so here the steering error. This display one. Okay, now we want to make it the control. The steering error. Now we added with the steering angle control. Yeah, this is the steering angle control. Steering angle control. That steering angle control I changed to the control. Okay, now indicator. Now I change to the control. This value added with the numeric, the addition need added. adder. So I put the adder connected to the adder plus this updated control. So now it is the display the new error, numeric and numeric indicator. This is for your new error or updated error. New so new error and it is just display one. Display the value. So just schedule this. Okay. So this is the land position. This is find the land error. So there is a steering. How much degree it is the change. The steering edge. So used by the steering angle control to change the error bar. I changed to the stop button. Create control. The stop button. I need the stopwatch. Now the timing. Wait in millisecond. Here create constant 100 millisecond. The 100 milliseconds. Now we needed the graph. Look at the graph. Waveform. This waveform graph for the steering error. How much error refer to the time? Yeah, so change to the refer steering error I taken. This is the degree. So I want to record the value. So model is the indexing. Now you look at about the block diagram and front panel. So it will stop. Move to the okay. So now we see in the land position. So for our decorations, I want to keep it the some image to here for your convenience. So how much position is there? So I taken the some image from the this one. Suppose this is the land keeping assistant. For your convenience, I keep it this image for your understanding. So I keep it this one as a here. Okay, so this is your for your convenience. And now we have to run the system. This is just to keep it the image. Run the system. So identify the your LAN error. The 0.5 means 0. No error. 0 error. Yeah. So there is no need for the any angle, steering angle control. No need for the any angle. This is your control one. This is 0, 1. Yeah. So 0. I want to sorry. Okay. I want to put the display, digital display. So this is digital display. Continuous running. I put the 0 position. 0 position means a error. So because the point is the middle position, so that the vehicle is run with the actual position. No error. I want to change the error. So the position changed to the 0.3. Now you see in that angle position is changed. Steering angle is the position is changed. Yeah. So now we are this much error is occurred. So minus 12 is the error is occurred. I want to put the plus 12. So this is the, we can achieve in the new error angle is the 0 value. So here is a negative value means just oppositely you have to change the steering position. Now I want to change to the 0.8. So suppose 0.9. So full variation. New error position is a 36 degree. I want to change to the minus 36 degree. So minus 36 degree means uh, this is the minus 12. How much? Here is the 26. I hope is the 26. 26, 24. Yeah. So we change the position to the 24 position, means that is maintained about the 0 here. New angle error is 0 bar. So this is we can able to control, and it is maintained about the constant steering. So we have 0 position without moving to the away in the land position. Yeah, this is the experiment for the land keeping assistant for your this experiment. Thank you.